y is equal with the cosecant x. We already know the cosecant x is related with the sine x. And first of all, let me draw the function sine x. We already know sine x has a period of 2 pi. Okay, it's here somewhere, 2 pi. And then this we divide in 4 intervals, equal intervals. And here is a pi, here is a 3 pi over 2. Those are critical points. And this is pi over 2. If we are drawing this here, the function is going to be something in this form. So of course the range is from -1 to 1, and those are the critical points here, and those are the critical points. Okay, so those are the critical points here and here. So let me draw this function. And so the graph of the function is going to look something this form. And this is going to repeat forever. Okay, and same thing is going in this side. Here is a minus pi and minus 2 pi. So same thing is going to go in this side. And whenever are those intercepts of the graph, it represents the vertical asymptote of the cosecant x. Those are vertical asymptotes of the cosecant x. Here is a 0, and it goes forever. And if we are drawing the cosecant x, we already know the cosecant x is a start from the values of the extreme values, minimum and maximum. So those are the points where it's going to start. And if we are drawing, for example, the cosecant x, let me draw with the blue one. Those are going to be in this point here. Okay, so this going here is not the sketch is not so beautiful, but if we are drawing in graphing utilities, those would look much better, because those are in the scale in the graphing utilities. So, and now if we are looking to find the inverse function of the cosecant x analytically, we already know from previously we changed those variables x and y, and this becomes y. Okay, we exchange and we are multiplying by the inverse of cosine x both sides. So this is the inverse of cosine of cosecant. I'm sorry, let me take this out here. Okay, with the cosecant both sides, and we get a cosecant inverse of x is equal with a cosecant and a cosecant inverse of y. This become 1, and 1 times y is y. So analytically, this is how we get the inverse of cosecant x. But now, if we are drawing here, analytically it's hard to verify. But if we want to, for example, graphically, when we are constructing here the line y is equal with the x, and we are trying to find what is the inverse function between the cosecant and inverse function. And if those, for example, are symmetrical with respect to y-axis, we know what is the inverse. But first of all, let me state on that one. Before we do anything, we have to verify does it pass the horizontal test. But this function, cosecant x, does not pass the horizontal test. Therefore, we have to restrict the domain. To restrict the domain, we have to restrict, for example, from here from in this point. But in this point is a pi over 2. Okay? And here is a minus pi over 2. If we are restricting this domain, so from this interval between minus pi over 2 and pi over 2, and we are drawing from 0 to pi over 2, we are drawing a horizontal line. This graph is going to pass a horizontal test. Also, if we are restricting from 0, from minus pi over 2 to 0, the domain, then this graph, this part of the graph is going to pass the horizontal test. So the inverse function, the cosecant x is going to have inverse function just in the interval of the function when we have a cosecant x, from minus pi over 2 to pi over 2. But again, if we are drawing here by hand everything, because we have a lots of line and those are not in the scale, is going to be very messy. But if we are drawing, for example, with the graphing utilities, and we're going to have a better picture, like in this case here. So here we have a better picture. And if we are looking here, so just let me take, if I can put this picture a little bit more, okay? So that's how it looks, this graph of the function. So from 0 to pi over 2 is this graph of the function. Cosecant x is symmetrical with the inverse function, with the green one here, in this interval from 0 to pi over 2. So with this graph from minus 1 to infinity, this one here. So this graph, this part. And the other part here, as I said, from minus pi over 2 to 0 is symmetrical, this red graph of the function with the inverse function, with the green function here with respect to y is equal with x. So this is the inverse function. So the inverse function has the domain from minus infinity to minus 1 and from 1 to infinity. Also, it has the range. The range is from minus pi over 2 to 0, and is from 0 to pi over 2. So this is the domain. In other words, the whole domain is from minus pi over 2 to pi over 2. But if you want to look a little bit better and to interpret more, this more, okay, if we want to interpret more in the better way, we can look at this picture here. And this is the graph of the inverse cosecant x. If you're looking for the domain, so just let me write about the domain here. So the domain here is from minus infinity to minus 1. In union is from 1 to infinity. So includes 1, minus 1 and 1 are included in the domain. But if we are looking the range here, the range starts from minus pi over 2, so includes minus pi over 2. So this is the range, minus pi over 2, and it goes to 0, but 0 is not part of the domain, so is excluded. And union is from 0 to pi over 2, but pi over 2 is included in the domain. So in this, the domain is in this closed open interval from minus pi over 2 to 0, and in the open closed interval from 0 to pi over 2.